Hey guys, so we are continuing the exploration of the tutorial PDF for Python documentation. So today we'll be talking about defining functions, and how we define function is by introducing the def keyword. So def keyword introduces a function definition, and it must be followed by the name of the function, parenthesized list of formal parameters, and so this is the def keyword. This would be the name of the function. This n here is the parameter of the function which would be passed, and in the parenthesized list format, so just comma separated values of arguments or parameters, whatever you would like to call them. And the statements that form the body of the function start at the next line and must be indented. So whatever is indented at the next line, this would be inside of a function, and as soon as we get rid of that indent, uh, or we just get out of that indent and just write some other code, the function is finished right there when we get out of the indent. And the first statement of the function body can optionally be a string literal. So this string literal is the function's documentation string or a doc string. So doc string are just a way to tell people what your function actually does. This is optional, but really helpful for someone who isn't part of your project, or who hasn't looked into your function if it's something complex. And the doc string would then give him or her the inside of the function, and it would be really helpful. It's like a mini documentation inside of your own function. And there are some tools which use docstring to automatically produce online and printed documentation, so that's pretty helpful for a beginner. And you can have strings right here in double quotes or single quotes or triple quotes even. These are triple quotes, triple double quotes actually. It could be triple single quotes as well, to write a multi-line string. So that's document strings summarized. We have it later on in the document as well. We'll talk about it more. And it's actually good practice to include doc strings in your functions. So that's an optional thing, but we'll look into how execution of a function takes place. So the execution of function introduces a new symbol table used for local variables of the function. More precisely, all variable assignments of the function store the value in a local symbol table. So symbol table is basically namespace. So namespaces and scopes in Python are very important, and understanding them can give you an edge over other Python developers, and you should know about this. So we'll get to know about namespaces and scopes later on in this tutorial PDF. But for now, let's just say that we have four symbol tables or namespaces and scopes as well. So that would be local namespace, enclosing, and the global, and then the built-in namespace. We will talk about this later. We have a separate module for this. And global variables or variables of the enclosing functions cannot be directly assigned a value within a function unless global variables named in a global statement, or variables of enclosing functions named in non-local statement, although they may be referenced. So yeah, the global and non-local or enclosing variables can be referenced in the inside of the function, and they can be used, or just reference their value. We can print them, we can basically read them, do anything with them, but we can't write them. We can't override the values whichever was assigned to them in the global and enclosing scopes. We can't do that unless they are followed by the global statement and non-local statement. These are keywords used to specify that a variable belongs to which scope. Global scope, keyword means the global scope. Non-local means the enclosing scope, and that variable would then refer to the non-local and or global version of itself, and then we can change or modify the global and enclosing variables in the function itself, the local scope of the function. So That's not encouraged, but we can do that in Python. So that's that. And argument, the actual parameters or arguments to a function call are introduced in a local symbol table of the function when it is called. Thus, the arguments are passed using call by value, where the value is always an object reference, not the value of the object. So this is very important. In Python, always the value is passed by object reference. So if you don't know about object reference, it is just that when a certain value is pointing to uh, so if a variable name, here let me give you an example. So here a is pointing to 0 and b is pointing to 1. So this means that a has a value of 0 and b has a value of 1. So in Python, whenever you pass variables, here we have passed 2000 in place of n right here. So what was passed actually? So here 2000 is just a value. So the value was passed. We don't have it as a variable here or something. But if you had a variable right here, the object reference would be passed. So the object would be the actual value where the variable is pointing. If we had something like x equals 2000 and we did fib x right here in inside of the parentheses, so x would be passed, the reference would be passed, not the actual value 2000 of that reference. So that's how it works. If it was passed by value, if Python was passed by value instead of passed by object reference or passed by reference, so we would then if we would then change something inside of the function, the actual value would be changed, because the reference variable would be pointing to the value and we change the value. And if Python was changed by value, the actual value would be changed, but that doesn't happen. We just change the when we do this, like assign a is currently 0, and when then we assign a to b. So it's not like we are assigning a to like b itself. It's giving it the reference to 1. So when we are saying a equals b, it's actually a equals whatever is b pointing to. So b is pointing to 1 currently. For the first iteration it would be, so it would point to 1 then. So if b is pointing to 1, a would be also pointing to 1. And that's how pass by reference works. And Python, objects are passed by reference, not by value. So that was that. When a function calls another function or calls itself recursively, new local symbol table is created for that call. So yeah, it's self-explanatory. We just here discussed that execution of a function introduces a new symbol table. So when it is calling itself recursively or calling another function, why won't it do it again? So yeah, for any number of calls to that function, it would generate a new local symbol table for that call. Function definition associates the function name with the function object in the current symbol table. So uh, in the symbol table or namespace as it's called, the function definition, which would be fib right here, fib would be pointing to the actual function object, which is at this memory address for this example right here. When we do just fib here, we get the like what it is and where it's located at in the memory, actual memory of the computer. So this is a memory address, and it's said that it's a function named fib at the memory address, which is right here. So as we discussed, that the function definition associates the function name with the function object. So this name fib is associated with the function object, which is stored here. So we can, as we know, Python is passed by reference. So this would be the reference to the function which is stored right here, and we just assign the reference to variable f right here. So we can then call f as we would call the function fib the same way, and it would work the same, because both fib and f are referring to the same memory address and the same function object. So that's uh, that's uh, that's how functions are in the namespace. Just the name of the function referring to the function object. So, and the interpreter recognizes the function object pointed to that name as a user defined function. So yeah, the user defined function, I mean it is in the namespace, and as this object pointed. Yep, that's self-explanatory. Other names can also point to that same function object and can also be used to access the function. So just whatever is defined here and what I explained right now, same thing is written over here. And let me just give you an insight of global statement and non-local statement and how it's used. And for that I have something new for you. So ta-da, this is PyCharm Community Edition. You can download this. It is, I mean, what's the site called? I guess it's JetBrains. Yeah, JetBrains is the company behind this, and it has PyCharm, the Python IDE. You can download this. Download the community version, which is free. So yeah. So we have this is global.py. This is for example of the global statement right here, and we have non-local.py here for the non-local or enclosing statements. So we have a value equals something. So the value is something. You want value to be something, and for the definition, I mean for the function func, we have value as something else entirely. So when we print value inside of the function, it would print something else entirely, and when we print value right here, it would print something. So let's just run this. Let me tell you why after I run this. So yeah, so this is just a function definition. We didn't call the function or anything right here, just a definition, and this is just an assignment to a variable. So these lines don't do anything. This this on the other hand is calling the function. So we invoke the function. Function is now running, and value is something else entirely. We print the value, we get out of the function. The function was called right here, so we get out of this line right here, and then we print the value which is something. And why is that? Because for the whenever the function is invoked, we have a new what was that called, a namespace, or yeah, it was called I mean it is namespace, but what was it called right here? New symbol table. Yeah, so a new symbol table is created when the function is invoked. The new symbol table, what would it have? It would have value which would equal to something else entirely. And if you had a function inside another function, it would have the function name, I mean the function name and the whole function object, it would point to the reference. So that's what the what's it called? I forget man. What's it called? Symbol table and or namespace. So that's why we have the local namespace right here. We would search in local first, then enclosing, then global, and then built-in. So we have value here, which you would like to print. So it searches where is value. Value is right here in the local namespace. It prints whatever is in the local namespace. If we do it like this, we comment this. This was done by control and so holding control and then forward slash. This is called a comment. We discussed this in the previous videos. If I run this, it is just printing something, because it searches right here. When we call this function, it invokes the function, and we'll have to print a value. It searches like, is value variable in the local namespace? It's like, no, it's not there. Then it searches in the enclosing namespace. It is value there. So we have a value right here in the enclosing namespace. I mean, this is actually the global namespace because it is on the module level. This is not enclosing. So that's why yeah, we have a value in the global namespace, and just print the value, and then get out of the function, print the value again which is in the global namespace, and we print something 2 times. So that's how it was done. And if we want to if we want to change the value in the global namespace, we would do here global. We would do something like global and then the name, so value right here. And what that would do is, when we invoke the function, it would go to the first line. It reads global value. So this line would mean that the value variable is global, and we would like to modify or play with the global value right here. We don't want to introduce a new what's it variable in the namespace. We just wanted to use the global variable and bring it into the namespace of the function right here, the local namespace. So this would bring this so the reference to this value in the local namespace, and then we point it to something else entirely. So the reference which the variable was pointing to, we just point it to something else, so something else entirely, and then we print it and we get out of the function, and then we print the value again, value here in the global namespace, mind that. So when we run this, we get something else entirely and something else entirely. So why was that? Because when we did this, when we wrote the global value right here, this meant that we were playing with the global namespace, the variable global value in the global namespace. So when we do this, then we assign something else entirely to the variable value. We do that for the like global namespace as well. And so when we print this, we get as like what we expect, something else entirely. But when we then print the value for the global namespace, we also get something else entirely, because we override the value right here for the global value. Got it? So that's how the global statement works. And now to the non-local statement. So the non-local statement, oops, not this, not global, so non-local. Here we have two functions. So the fun this is defined at the module level. So this is the first level. So this would be this as I told you, anything indented after a function definition would be inside of that function. So this entire thing is inside the function fun, and too much fun has this thing inside of it. So we can say fun is enclosing too much fun, or like fun is the enclosing function of too much fun. So yeah, what we do here is we define the function fun and have value something in it, and then we define too much fun at the same level, and we have value something else entirely, and we print the value. We call too much fun, and then we print the value again, and we call function. So what it would do, let's just run this, and we get something else entirely and something after that. So when we see, this is just the function definition of fun. Nothing happens right here. Nothing happens if you don't call the function right here at line number 12. If you don't call this function, none of this will execute, and it would just be blank. Everything would be blank. But since we called the function fun right here, it would call it would invoke the function. And this is actually a great example. We would, for namespaces, we would have the variable value right here, and its value would be something in the namespace, and we would have too much fun as the value, as the key in the namespace, and its value would be the entire function, this entire function. And yeah, that's how you would access it. And if you call too much too much fun right here, you would invoke this function, and you would set the value something else entirely. You would print the value, which is something else entirely, and then you would get out of this function where it was called. So it was called at line 8, so we get out of at line 8, and then we print the value. We check the value right here, which we are about to print in the local namespace, or local, what was that again, symbol table, yeah. Symbol table. And the local symbol table consists of these many things. for the fun function. So these many things have value in it, and we would print value whatever is right here, and then we would get out of this function. So get out of line 12, and the program just ends. So that's how we print something else entirely and then something. Okay, you got it. So what if we want to then modify the value right here in function fun? Okay, that's not the global scope. Let's try global. Let's try global value as we did in the previous example, and let's run this. No change. I ran it actually. Let's do it again. No change, because this value variable isn't in the global namespace. That would be this variable. Like if we do something like, oops, not that. If we do something like value right here, and if it equals whatever, so if it has whatever, and after the function we print value. So what do you think we'd have? So let me tell you. We invoke function, we get into the function, we set a value, and we set too much fun in the namespace, and then we get to this line where we call too much fun. We call too much fun, we go into too much fun. We say, hey, I want to change the global variable value, and change it to something else entirely, and then print the value here. It would scan through the namespaces. So first of all comes the local namespace. So hey, do we have value in the local namespace? And yes, we do, which is something else entirely. So it prints something else entirely. This isn't the program we have right here. We haven't run this, but I'm just walking you through it. So this would print something else entirely, and then we get out of here. We print value for this namespace, the uh, fun function local namespace, and that has value as something. So then we would have printed something, and then we would get out of the function call of the fun function, and then we print the global value. And the global value, we just overrid it here, so it would print something else entirely. So it would be something else entirely, and then something, and then something else entirely. Watch this. How cool is that? So that's the use of the global right here. And if we do it as non-local, yeah, so if it is non-local, it just does the same thing. You can watch this video again once more, but it does the same thing as global right here, as global was explained by me, but it does it for the enclosing namespace. So enclosing namespace for the function too much fun would be the function fun, and it would change the value right here. So so what would happen is, I just skip to right here. uh, so let me just go over it again. So this is the global namespace. We would have value whatever, and the function definition of fun right here, and it referring to the object, function object. And yeah, so we have that right here, and we call fun, so we get into it. And we have for its local namespace the too much fun and the value something. Too much fun would refer to the function object too much, like the name too much fun would refer to its function object in the namespace. And then we call too much fun, so we get into it. And non-local, we are telling this function, hey, check the non-local variable named value. So this is it. Hey, yeah, we have it. And then we assign something else entirely to that variable value. So something is replaced with something else entirely, and then we print the value right here. And this would search in the local namespace. Do we have value variable? And we do, which is something else entirely. So we print something else entirely. We get out of the function call right here. We print the value, print value for this namespace, so local namespace of the fun function. And this was changed from something to something else entirely, because we changed the non-local value. So this prints something else entirely, and then also something else entirely, and then whatever. So let's run this. See, something else entirely, and whatever. So that's how local and like non-local and global statements work. And yeah, that would be it. So coming from other languages, you might object that fib is not a function but a procedure, since it doesn't return a value. But in fact, even without a return statement, it does return a value, which is which is a boring one. This value is called none. It is a built-in name, and writing the value none normally suppressed by the interpreter. So it would be only like if it's the only value which would be written, it isn't written. So yeah, you can print it. As we saw, like print statement has some like different syntax from let let's just go into join 3. Let's just go into the interpreter. If we print here name, if we just say name equals something, and we did name right here, we would get something like something enclosed in single quotes. And if we print name right here, we have something like the string something, but not enclosed in anything. If we do none right here, we get nothing, because if none is the only value to be printed, it just doesn't print it. But if you want to really see none, we can print none, and it's shown right here. It's just none. So that's what the documentation said. It's a rather boring one. So yeah, that's it. If a function returns nothing, it returns none, but it usually isn't shown by the interpreter. And it is simple to write a function that returns a list of numbers, Fibonacci series, instead of printing it. So yeah, it can return number. This would be self-explanatory. If you have been following along till now, this whole example would be self-explanatory to you. And yeah, this is append. We talked about it in the list section of the module, previous video just before this one. And yeah, nothing new. More on defining functions. So it is also possible. Yeah, variable number of arguments doesn't this doesn't really have to be just one argument. We can have many arguments, and it can be of like many types, and yeah, which can be combined. Three forms. Yeah, we have three forms of arguments, which are default arguments, and then we have keyword arguments, and we have positional arguments. Where is it? Positional or keyword, yeah. And we can define that. Let's just go one by one. So default argument values, these are most useful when we have to specify the default value for one or more arguments. This creates a function that can be called with fewer arguments than it is defined to allow. Yeah. So when we have a function like this, ask okay, and we have here 1, 2, and 3 arguments. But if we give it default arguments by just doing like an argument equals its default value, so retries equals 4, and reminder equals please try again. If we have it like predefined right here, so as we assign value to variables, if we have it in the function definition itself as parameters, if how that would work is, if we provide just a single argument for this function, it would go into prompt as a positional argument. And if we provide like two arguments for this function, it would first the first one would go into prompt, second would go into retries, and reminder would be just the default value, please try again. And if you had 3 arguments for this function, first would go into prompt, second one into retries, third one into the reminder. And yeah, that's actually it for the default argument values. And yeah, so giving only one mandatory argument. Yeah, and this argument would be mandatory because it is like no default value set for this for, so this would be mandatory to provide, and these would be optional. Then the arguments with the default values would be optional, and that's how you set up optional arguments in Python. So this example also introduced in keyword where this tests whether sequence contains a certain value, and default values for you. Oops. So let's see. We have I right here, and I equals 6. Yeah, of course. I mean, this is explanatory, so self-explanatory. So if you have I equals 5 right here, and we define the function right here, and it says arg equals I, which would be its default value. So I is defined right here, and the value is 5, but like we don't have it in. We don't have. We don't pass I right here. If we passed I, the value would be 6, but we didn't, so the it would just go to the default, and default is I defined right here before the function itself. So this would print 5. That's uh, that's like pretty basic. So warning, the default value is evaluated only once. This makes the difference when the default might be mutable object. Yeah. So passing in mutable objects is a interesting thing in Python. If we pass mutable objects like lists in Python, we can append to the list inside of the function and then return the list. And the list, which was right here, I mean here it's an empty list. So like the list itself, if it isn't defined outside the function, it would just be for the function namespace. For so the local whatever it was, let's just call it namespace because that's what it is. So that would be just for the local namespace, but if the list L was defined before the function definition right here, the original list named L would be then modified. Yeah. So yeah, if you don't want to the default to be shared between the subsequent calls, you can write the function as like this. So the function definition, and then the parameter right here a, and L equals none. And if L is none, then it's an empty list, and we can append to L and then return L. That would be for this function call. And if we call this recursively or have some other value right here, if L is not none, we would just append a to L and return L for that function call itself. And yeah. So that was that. And we have keyword arguments right here. So function can also be called using keyword arguments, a form of the form. So keyword argument equals the value for it. For instance, the following function. Yeah. So this function, this has so voltage right here. Yeah. So keyword arguments, actually we don't like we can get confused for keyword arguments and default arguments right here between those two, because default arguments are just in the function definition. We have it equal to some value, so this would be the key, the retries would be the key, and 4 would be the value, reminder would be the key, and please try again would be the value right here for the default argument. And so keyword argument is similar. I mean, sin I mean, if you are first beginner in Python, it would seem similar because we just call the function and we pass it as voltage equals whatever it is, 1 million maybe, and action is equal to boom. Am I reading that correct? Okay, action is equal to okay. And yeah, so that would be keyword argument. That would be a keyword argument. And how it works is this till now whatever we passed, it was like a positional argument. So parrot 1000 right here is a positional argument. So whatever parameter here is at the position first would receive the 1000 as its value for that function call, for this function call itself. So voltage right here would receive the value of 1000, and these are optional and default as we just saw in the previous example. So this would be a valid function call, and voltage would be 1000 for that function call. This would be also a valid function call, but we are specifying here that the voltage equals 1000. So the position doesn't matter right here, but uh, we would have, like, this just tells that the voltage is 1000, and other things would also, like, it can be jumbled right here. The arguments which are not default or which are required, those can be jumbled right here, but if they are in the keyword argument format, it would just go to that argument, and not to another one based on the position. It would just go to the one we have right here. So it's shown right here. See, voltage equals 1 million right here, and action equals boom. This is also valid method call, because when we have voltage right here, it's 1 million, and then it goes like state. Did we pass state? No, we didn't. So it takes the default value. Did we pass action? So yeah, we pass action. It has this value, so that would be the value for this function call right here. And then did we pass type? No, we didn't. So it just takes the default type. So that's how we use keyword arguments, and this could come in handy when we know the argument, like the when we know the value of so as we discussed, these calls would be valid, and why they would be valid, we discussed that as well. This call would be valid. uh, would it be valid? Action boom, and then voltage. Yeah, it would be valid because both of them are keyword arguments, and yeah, it would be valid then. This has two keyword arguments, yes, three positional arguments and one positional, one keyword. So the positional argument would just go to whatever is, like, the, like, according to the position, million would go to voltage. What's this, whatever this is, would go to state, and action would be jump here, and 1000 would go to voltage right here. State would be pushing up the daisies, and action and this would be optional, because those are default, by default, in the function definition. But as you can see, these function calls would be invalid, and let me tell you why. Parrot without an argument requires a required argument missing. So this argument right here, voltage, is required because it isn't defined right here by default. So that's a required argument. We can't have it missing. So this function call, non-keyword argument after keyword argument. So why this is why is this why is this invalid? So we have voltage right here set to 5.0. That would be the first thing, and then we have non-keyword argument, so just a normal argument, positional argument after a keyword argument. So that's really not how you write things in Python. We would have keyword arguments first, and then the non-keyword arguments. It's told right here, I think, in a function call, keyword arguments must follow positional arguments. Yeah, so we always have positional arguments first and then keyword arguments, because positional arguments, they are based on the position, right? So the position of like, the position is important first. We can have keyword arguments on in whatever order we do. If all of them were keyword arguments, we can have them in any order in the function call, and it would work the same. But for positional arguments, we would it the position holds significance, so that's why it's called a positional argument. That should be self-explanatory. and all the keyword arguments are passed must match one of the arguments accepted by the function. So yeah, so the order is first positional arguments and then keyword arguments, and the keyword argument should match the whatever the function is expecting, it should match it. If it doesn't, that's also invalid. And duplicate value for the same argument, so we pass here a positional argument of 110, and the first position is voltage, but we then pass the keyword argument voltage equals 220, so that's the duplicate value. Python doesn't know which value to give to voltage, so it's just confused. And unknown keyword argument, so actor John Clays, I don't know who he is, but still we don't have it in defined in the function statement. So the function definition, we can't have it here. We would need something. Where was it? Yeah. So must match one of the arguments accepted by the function. So this doesn't. It's not valid. And their order is not important. So keyword arguments, the order is not important. This also include non-optional arguments. Yeah, no argument may receive a value more than once, so this can't happen. And yep, yeah, so got multiple values for a argument. So this is a example of this duplicate value for the same argument. When a final formal parameter of form asterisk name is present, it receives a dictionary containing all keyword arguments except for the one corresponding the formal parameter. So this is just replacement for keyword arguments if we want to pass in multiple, or just unpack a dictionary in place of this, that can be passed into the function. So yeah, this syntax is for keywords, this syntax is for arguments, and here it says like it receives a dictionary, and here it should be a tuple. Yeah, it contains a tuple as a positional argument beyond the formal parameter list. Yeah, so yeah, as we discussed that positional arguments must be before the keyword arguments. So this basically is a keyword argument because we pass a dictionary right here, and these are positional arguments because I mean whatever is after the actual positional arguments, we want to pass a tuple and we want to unpack it, we want to pass a dictionary and unpack it, we just have to have this in order. Just our normal our normal arguments right here, which we pass as positional arguments, which we pass as tuple, and which we pass as dictionaries. So just the same rule applies, that the uh, keyword arguments must follow positional arguments. So keyword arguments must follow positional arguments, the rule still follows. And yeah, uh, everything which is not inside of this tuple and we want it as a argument should be before this as positional arguments, or keyword. No, not keyword, because this would then change the order of the keywords and positional arguments. So if we define a function like this, we can have, yeah, have it like this. So kw in keywords, so that would be the value, that would be the key actually. So key, and we print arguments. So just printing the tuple, printing the key and value of the dictionary. So that's that, we are doing that here. And yeah, it would print this. And then we have special parameters. So special parameters are parameters, so by default arguments may be passed in a Python function either by positional or explicitly by a keyword. For readability and performance, it makes sense to restrict the way arguments can be passed, so that the developer need only look at the function definition to determine if its items are passed by position or by keyword, or by both. keyword or by keyword or is it duplicate? So pass by position or okay. So by position or keyword, or just by keyword, those three things. So yeah, a function definition may look like this. So we have positional arguments here, and we have positional or keyword arguments here, and then we have keyword only arguments right here. So we can have positional arguments at first, and we can have positional or keyword arguments right here, but or is like in this itself we would have positional first and keyword next. That's how it works. So where slash and asterisk are optional if used, these symbols indicate that the kind of parameter by how arguments may be passed to the function. Positional only, positional or keyword only keyword parameters are also referred to as named parameters. Okay, so yeah, this self-explanatory. Let me tell you about this one. So positional only arguments. So this is how we tell a function, like by looking at a function, that what kind of arguments it can accept and it does accept. So to mark the parameter as keyword only, indicating the parameter must be passed by keyword arguments, place an asterisk in the argument list just before the keyword argument only parameter. Okay, we didn't talk about positional only parameters, so we'll take a look at this as well. So if positional only parameters, so the parameters for which the order matters and parameter cannot be passed by keyword, positional arguments parameters are placed before a forward slash, and the forward slash is used to logically separate the positional arguments and from the rest of the parameters. If there are no forward slashes in the function definition, there are no positional only parameters. Yep. So this enforces the user to pass in positional only parameters and keyword only parameters. uh, this right here, we can have any type of parameter right here. Positional would be the 0th position, so the first position would be, uh, if we pass anything right here as the position, so standard arg, we pass 0 here, we'll print 0. If you pass arg equals 0, we would still print 0. So positional or like keyword, it won't matter here, but for this function we would have to have it as positional. Yep, this is for positional only, and we would have to have positional argument right here for arg, and here we would have to have keyword argument. So and the combined one is right here. So positional only arguments, and like before forward slash we have positional only arguments, and after asterisk we have keyword only arguments, and in between we can have standard arguments. So it can be accessed by position or keyword. So yeah, so first function definition, we have no restrictions for calling the for the calling convention of the function. So this we have no restrictions, but yeah, it can be accessed by both of these. For the second one, we have positional only arguments. It was a forward slash, so we will have to give it like this. If we pass in like keyword arguments, it says type error. No, you can't do that. Got some positional only arguments passed as a keyword, so it expects positional only, and you are passing keyword, it says you can't do that. No, gives an type error. So if you do this, if you have an asterisk before the arguments, they should be keywords, but if you pass positional arguments right there, it says like it takes 0 positional arguments, but one was given. Why are you doing this? It expects keyword arguments, and for keyword arguments you would have to match the name which was in the function definition, so you would have to know the name. uh, so the last one uses all three of them. We have it like this, I mean like this. So positional only before the forward slash, and after the asterisk we have keyword only, and in between we can have any, so both. This is the example. We have 1 2 3 optional, positional 1 to 3, it gives us type error because we we expect, what do we expect right here? Yeah, we expect this to be a keyword argument, and it's not. It is right here a keyword argument, so we get 1 to 3. And here see, we can have this middle argument as positional or keyword. It won't matter, it would still give us 1 to 3. But if the first one is uh, keyword argument is passed as a keyword argument, it would have some problems. It would need positional, but you passed in keyword, so that's wrong. Resistant type error. Finally, consider this function definition, which has a potential collision between the positional arguments name and keywords, which has name as a key. So yeah, this function definition, there is no possible call that will make it return true, as the keyword name will always bind to the first parameter of the, like, for example right here, for if we if for this function we pass in a positional argument of 1 as a name, and then we pass here, right, name as 2. So if we say, if return name in keywords, so name, the string name would be always referring to forgot multiple values for the argument name, because this would refer to the name right here, and we would have name right here as well as 2 in the keyword argument, so it would be confused, just as it was confused in the duplicate arguments, which was right here. Yep, duplicate arguments. We had positional argument for voltage as 110, and the keyword argument says it's 220. So Python can't make sense of this. Like, what are you doing? No. So that's it. Multiple arguments. And what do we have next? Using positional only arguments, it is possible, since it allows name as a positional argument and name as a keyword argument. So if you have it something like this would resolve it, like, hey, so remember we passed name right here, so that's just a positional argument, so you can have one as name, the variable, and then you can just unpack the dictionary which I passed right here. So this is the dictionary, you can unpack it and have the string name as the value of 2. So if we then say that the string name is in keywords, it says yeah, it's in keyword, so it returns true. It's in keywords with the value of 2. So that was it. Recap, we don't need recap till you watch my videos carefully. You don't need recap, just watch the video again. And arbitrary argument lists. So this is finally the least frequently used option to specify that the function can be called with arbitrary number of arguments, would be wrapped in a tuple. Okay. And yeah, so we have right here arbitrary arguments. We can do is have files right here, separator, and then args would be a tuple, which this function would then unpack. So args can have, we can it's basically positional or keyword arguments. So these two can have positional arguments, and whatever positional argument is after that would be into args. So it would be uh, like inside of a tuple, and we can then index the tuple. We have seen tuple and indexing, so you can do it. Normally these Vedic arguments will be last in the list of formal parameters. Yep, because they scoop up all remaining input arguments that are passed into the function. Any formal parameters which occur after the args parameters are keyword only arguments. Yep. So meaning that they can only be used as keyword rather than positional arguments. Yep. So we have these which can be positional or keywords, and this has to be positional because whatever comes after these two, I mean, first of all, we have the order. I mean, we have the order rule where positional arguments must come after the keyword arguments. So these have to be positional arguments. So whatever you pass into this function, write multiple items, uh, these would have to be positional arguments. So the first positional argument would be a file, second would be a separator, and then third, fourth, fifth, sixth, whatever, that would be inside of this args, and you can index args inside of the function. That would give you the whatever positional argument you passed right here. And after args, you can only have keyword arguments, because if you pass positional arguments, that would just be part of args. And if you want other arguments after args, those would have to be keyword arguments. And those can be like separate keyword arguments, or they can be like asterisk double asterisk, uh, KWARGS, so keyword arguments, as we saw before. So what's this? Yeah, we are just joining args. So yeah, separator is this, args are like whatever we pass right here, it's separated by this and joined. So we just whatever we pass right here, we pass like separate it with the separator. So yeah, these are all positional arguments in the args, and separator, we join it with the separator. Yep. So that's it. And lambda expressions, we would see that in the next lecture. Unpacking argument lists. So these are arbitrary argument lists, where if you pass more things, like here we expect three things. If we pass more than three things, it would be stored as a tuple in here. Or if we had double asterisk, and we would have passed what we call key value pair, so it would be stored in the KW args, or like whatever is after the double asterisk. These args and quarks is just a placeholder. Main syntax is this asterisk and double asterisk. So unpacking argument list. So this is a reverse situation, where we don't pass multiple arguments right here. We pass a tuple or a dictionary within the arguments, and we then unpack it when we are in the function call. So yeah, right here, normal call with separate arguments. Yeah, so in the list function, we are passing a function which returns an iterable of like 3 to 5. Yeah, so then it would be converted to a list. And yeah, this is the same 3 and 6 right here. And we unpack it. So the range function, it took the args was a list which was then unpacked, the first value being 3, and second value being 6. So it was unpacked for the range function, and the first value, which is the start, is 3, end is 6. So it end is exclusive, start is inclusive. So it did the same thing as this. It should be self-explanatory, as we unpacked from the list, which was args. So same fashion, dictionaries can deliver with the double asterisk operator. And what we can do is, we can have a dictionary like this, and pass it in the function. And it would just unpack these values. So the voltage would have 4 million as value, state would have bleeding demised, bleeding devised. I just thought the string ended here because there is a code, but everything is enclosed in double quote, so this doesn't make any difference. It's inside of the string now. So action is boom, and we have it satisfying all the conditions right here. All the three parameters are included in the dictionary, and we have the same names of the keys. So this is how it would go. So all good. We learned about unpacking the arbitrary arguments and unpacking tuples and dictionaries. We'll talk about lambda expressions in the next one. Thanks.